Well, hi, good morning. I thought we'd start off by looking out at the beautiful day we've got going here. It's very cold, about minus 15 out there, and beautiful sunshine all day. That's what that's what this is. This is the sun. That's how it looks in my camera. And interestingly enough, this is looking out of the upstairs of my house, out the front. If you look over here, you look right there, that line you can see there, it's the same line. It's very hard to see over here. That's the far shoreline of Lake Couchiching. That's 2 miles away. The lake is here. The lake is about 2 miles wide. It's about 3 kilometers wide at this point. And the shoreline comes up a couple hundred feet below my house here. Where there's another street down here, more houses than that, but it's hard to tell. But I'm actually quite close to the lakeshore here. So it's a beautiful, beautiful day outside. That's a great way to start. Okay, so I hope to do a lot more action today and a lot less talk, but I'm going to start out with some talk. I was in here yesterday evening and I got out my ohm meter. I even tried using this meter as an ohm meter, but I kind of gave up on that. I used my digital meter. I checked all the resistors that you can find in here, that I could find. They all test pretty good, actually. They're all pretty close. Now there's some precision resistors in here. These three here are 1% resistors. I'm pretty sure these green ones are high precision wire wound resistors. There's this guy here. It's also a 1% resistor. A couple more over here. So I checked those very carefully. They all seem okay. This one measures a little low. In fact, let's check it again. Maybe after a good night's sleep, it's regained its strength. Now I'm testing all these in the circuit, so it's a little questionable all the time. So that reads 140, and on the resistor it says 133, 1%. Well, 133, 1% is another 1, so 134. So it should be 132 to 134, and it's 140. So I haven't changed any of these. There's another resistor in here. I don't know what to make of it. This one right here. It says on it quite clearly 38.83 ohms. Well, why would it ever say that kind of precision on a resistor? Let's see if I can get it on camera here. So, it's pretty clear to me, 38.83 ohms. I looked at this up and down, left and right. This measures 38 ohms. 0.83? Really? Can they actually do that? I just can't believe it. These other precision ones, like this one, it just is 41. Just 41, not 41.00. So I don't quite get that. But nevertheless, it measures right around 38 anyway. So the less precision resistors are all pretty much within 10% of their value. So consequently, I've made no changes to any resistors in here. But there certainly aren't any that are open circuited or have gone way high. That has not happened in here. Okay, so I think we're going to get on with the next couple steps here. And we'll finish off. We'll try to finish off as I'm sure we're going to have trouble with it, but we're going to try. Finish off the calibration procedures. Okay, let's take a look at what we're doing here. First, we're doing this emission calibration. So here's the steps I have to go through. Turn off the instrument and set up for an EM check of a 6L6 as shown below. This is interesting, connect a milliammeter, DC milliammeter, from the grid to the plate jacks on the front panel. It's very unusual. Use a meter with a full scale reading of at least 50 milliamps. Connect the negative side to the plate. Steps R, S, and T may be omitted by rotating potentiometer P11 to approximately 7 ohms when the wires going to it are disconnected. Oh my gosh, are you kidding me? This is not an accurate method as listed in steps R, S, and T. This is step R. I'm reading step R right now. But it is quite sufficient in most cases. So I think what they're saying here is you can skip this ammeter thing and do this other approach. But I certainly have a ammeter to do this with. Insert the 6L6. Ooh, don't miss that. Turn the instrument on, allow 30 seconds. Bias potentiometer for 20 milliamps of plate current on the DC milliammeter. Without changing any settings, adjust potentiometer P11 on power supply chassis for a reading of 3 on the 10 volt bias scale of the tube tester meter. So first you adjust the bias potentiometer to get this current flowing, and then it says without changing any settings. Okay, well, without changing any settings, then you just turn this and begin reading the, right, it's a different meter. What am I talking about? The milliamps are coming on my external meter. This is on the meter of the actual thing. Fine. Okay, that's good. We can do it. Didn't I say something about not talking too much? So just to add to the excitement here, I've included a few more instruments on the tube, which is something I intend to do anyway. I want to know what's really reaching this tube. So regardless of how all this appears to be working, I think you really got to take a look. So I've got a voltmeter on the grid. That's this one on the grid. I've got a voltmeter on the plate. That's this one that's going to be on the plate. Let me put it to the 500 scale here. DC positive, a DC negative, 15 volts, and excuse me, I've also connected the oscilloscope. The oscilloscope is currently connected to the grid, so we can see what is going on the grid. Now, the meters and the scope, they put a small load on here. I'm assuming it's not enough to throw everything off. That's an assumption. So I think we're ready to go, except I need to set this now for an EM test. Or should, you know what, this is set for a GM test. Why don't we run that, see what it looks like. Switch all the controls to the EM, run that. By the end of that, I should be ready to stop. Okay, that's a good idea. I like that idea. ABC, always be experimenting. So we're all set here, I'm sure, but let me just double check quickly. BG, AG, yeah, exactly. These are all different. Oh, you know why? When I was testing, good thing I checked. When I was testing the resistors, some of the readings I got were way off. I would move the switches that are associated with the resistor just to see if that would change it. And sure enough, in quite a few cases it did. And that left these things discombobulated. B, G, A, G. Let's do it right now. This EM doesn't matter on the GM test. 06431, 06431, 0520, 05200. The bias setting is supposed to be 1.4. Should be able to see that on this meter and this meter. The GM reading is supposed to be 5600 or so. And I think this too, I think it was didn't it test around 5000? The last time I did it, every time I do it, it's a little different. I think we're all set. 10 scale, line, off, test, on, good. Oop, not plugged in. Gives me one more chance to bail out here. Oh, I didn't put in the, I don't do the ammeter yet. I'll do the ammeter next. Because this test doesn't involve an ammeter. We're good. We're good. Go. Okay, line voltage. What happened there? I don't know if you saw that, but the meter went whoo. I'm not sure what happened there. Okay, anyway, it's come up nice. Oh. There's some kind of magic trick being played by the meter here. I don't think it's static. I don't know. Okay. Line is adjusted. Good. Fine. Next step, bias set to 1.4. So we should. So we have the bias reading here. I didn't come up here. Now, if I remember right, it won't come up till I put this into test mode, I believe. Let's not do that just yet. So 1.4, the bias is set on this meter. That's 1.4 there. Go back and check the line as you're supposed to. Line is fine. You're supposed to do this with the tube switched on hold in order to cause the currents to flow. Let's try that. So we're watching this meter, bias at 1.4. In test mode it's gone up a bit. Check the line. The line's gone down a bit. Of course. Line up. Bias. Bias down. 1.4. Right. 1.4. What have I done here? What's going on? I got something wrong on this meter. Something badly wrong on this meter. I've done something wrong here. Either I've done something wrong or there's a grid voltage like you wouldn't believe on here. DC plus. What's going on here? I must have got the two meters confused. So this must be the grid meter and this must be the plate meter. I tell you, I just wouldn't work out if I was a doctor. I'm sure of that. Just would not work out. Great big AC signal on here. Ugly AC signal on there. Did I get that messed up too? I probably did. Because I'm thinking I'm connecting it. Let's just double check here. Just hold on. Just hold on. Something stupid is happening. I am probably involved. So cathode on 8. That's what all these connections are. To pin 8. Cathode on 8. The signal grid is on 5. And the plate is on 3. Plate is 3. Green. I haven't done this wrong. Is the plate connections on here? You know what? I'm going to take this off hold for a sec here. What is going on? Plate is 3 and the grid is 5. Oh, okay. Double check my connections. I may have had two of them reversed there by accident. So let's carry on. Tube tester is not switched on at the moment. Let me get this ready here. Anticipate some kind of reading coming up on the meter. Kind of a weird view of it there, but I think that'll do for now. Okay, let's turn the guy back on. Everything's ready to go. These need to be switched around. Put on the high scale to start. Okay, this should be online. Off. Test. 10. And ready. GM test attempt again. Another attempt. So that's the line adjust voltage. It's a little high, but the test is not switched on at the moment. So let's take a look. So that's the situation with the line. I'm going to leave it like that, but let's look at some other stuff here. So the meters. Nothing showing on the grid. Might be a little bit on this meter. It looks like it's not quite zeroing properly. This is supposed to be the plate meter, so it should be going way up. So there's a good chance that what's being put on this tube isn't even DC, signal-wise. Yeah. So what's happening on the grid? Wow, there's just nothing showing up. Okay, so, we're gonna flip this into test mode on the hold. That'll cause the line to reflect what's really happening when the test is undergoing, being done, whatever the word is. So let's settle the line and the bias, and then we can move on from there. So That's what the test on. Okay, and of course what I've done now is I've grabbed the bias adjust and thrown it into nonsense because I grabbed the wrong control. That's a real problem with this tester. There's the line. It just doesn't want to. It doesn't quite want to sit right on it. Bias. Bias is supposed to be 1.4. That's just about where it is. Way down on this scale down here, which is kind of fuzzy. It says 1.4 to me. Okay. So at this point we've got almost 150 volts on the plate. Nothing showing up on the grid at all on the other meter. So I'm going to put this into test mode. The test switch is still in hold position. So that's the actual GM reading now we're getting. So again, totally different from previous tests. It's not very reassuring at all. What am I not doing right? I think I'm doing everything right. So we're on the 30, the 20 scale. That's this top scale up right up at the top here. So we would read that as just under 4. Just under 4,000. Just under 4,000. I read it at 5,000. I think I've also read it at 4,500. Like every time I do this test, it comes out a little differently. So, but by the way, I have really no hope of making any of these tube testers precision instruments again. All the ones I have. That's not what's in my head. I don't think I'm ever going to get there. In fact, I'd almost question whether these things are ever there, right from the day they come off the factory line. So, but the thing is, you can be in the ballpark and be very successful with these things. I mean, I test tubes all the time. I'm always aware that all the tests are a little wonky, but generally in this kind of shop, what I'm really looking for is the tube is completely dead or extremely weak. I'm not looking for precision GM. So I hadn't said that before, but in the back of my mind, I think it's a pretty hopeless attempt to make this thing precise. And how would I even ever know? So I get 3 machines that all give exactly the same reading on, let's say this tube. Maybe I adjust all the machines so they all give exactly the same GM reading on this exact tube. You think I'm going to put a totally different tube in here and continue to get exactly the same reading on 3 different machines? That's not going to happen. So I'm always going to have different readings on different machines. So when it comes to being a very, very precise result, it's not going to happen. Okay, enough talk. Why am I talking so much? I'm giving a lot of time for this stuff to sit here and heat up, and for me to figure out why didn't this meter come up? And the scope didn't come on. Well, there's a hint right there, isn't it? I got a bad clip lead. Did I clip on the wrong spot again? I'm on pin number 1, 2, 3. That's pin 3. I'm pretty sure that's the right pin. So sure, I'm going to check again. 50L6. 3 is the plate. 50L6. 3 is the plate. So this should be showing the plate voltage. Maybe. And it should be showing up on here. How come not here? It is showing up here. It's just puny. Let me give it a little more brightness there. That's the signal on the grid. Was somebody looking for a nice clean AC signal? So here, I'm seeing the voltage now. What is it with my fingers these days? I can drive every meter nuts here just by... It's got to be static electricity. Don't like the reading? Just recharge the face of your meter. So if I actually read this, it's a 15 volt scale. So that's, if it would stay still, that's about 3 volts. 3 volts, it looks like this though, and this is an AC signal. This is not DC. Wait a minute, let me flip it on DC. This is a mistake I've got here. That's better. And it should have had this like this. Let's just check the 0. 0's right in the middle. So you see, drop down. So that's a DC voltage with a piece of slop on top of it. DC voltage, this is 2 volts per division. So you could say it's got 1 volt of DC with a slop on it. Wow. I wanted to look, you know. Now I've seen it. Let's put the scope on the plate. We'll see what happens there. Put that up. This is the plate. Is that right, Jim? Yes. 3 plate. So this is shot right off here. Okay, check the 0. Oh, Peanut, you scared me that time. Yeah. What is it? What's the problem? Oh, we want some attention as usual. Bit of a routine happening with this cat. So we're starting here, 50 volts per division. So that's 150 volts just to get to the middle. Let me do that again. Whoops, I didn't want to do that. So it's starting right on the 0 line, going up, and I mean you can guess that this is a this looks like a full wave rectified, unfiltered. So this part is actually the sine wave from down here, flipped up. So it did say something in the manual about using pulsing DC, and I think this is what they mean. You know, unfiltered 60 cycles. Pulsing DC sounds better. So that's what's actually going on the tube. So this isn't the same thing like you know, puts a nice clean DC on here for B plus or something like that. Other tube testers may work differently, but I certainly noticed there's virtually I think no filter capacitors in here to smooth out any DC power supply. Probably wrong about that, but it wasn't obvious that that's what they were trying to do. Filter, like make a nice smooth DC in here. So where are we at? Didn't I say something about it was going to be a video of action with little talk, but it hasn't really turned out that way, has it? Set up the EM. Okay, that's right. That's that's what we're all ready for. Okay, let's just get something in our head here, in my head anyway. That's what the plate looks like. The voltage on it is 100, 220 from here to there. On the voltmeter, that is telling me, this voltmeter, it's 130 volts, according to the voltmeter. DC volts. That's what this thing translates into, I guess we could say. And on the grid, some schlocky looking signal. You know, shouldn't this look like the grid signal? It just disappears entirely when I turn the test off. Now, this didn't disappear entirely. Okay, good enough. This set off, test, leave everything just as is, power off. And now I will place my eyeballs upon the manual here, turn it off, set it up for an EM check, connect the milliammeter. Turned off, EM check, BEBD, get it right, E, that's EM, test, obviously. B, D. 6, just based on the dial here. 6. Sets of numbers are the same. Second set of numbers is the same. 0643. Oh, it's not the same. It goes from oh, get your eyes on the right. I'm reading the wrong lines here and everything. 06, yeah, it's the same across there, same across here. Bias now goes to 11 volts. And then what are you supposed to get from the, oh, the EM test is a good bad test. So there's no number here to check against. So all that's changing is just this top row. B, E, that's probably the case whenever you do these. Probably these all stay the same between the EM and GM. Jim says, trying to teach himself how to use this. B, E, B, D. B, E, B, D. 6. That's it. Test. Let's go to line. It's my first time doing an EM test here. Scary stuff. Switch on. Now you could be engaging other circuits in this for the first time that have never been energized the whole time this thing's been in my shop. I doubt it, but could be. So, like maybe this thing. Maybe something new will happen here. Everything's good. Give it the full shot. Now, there was some special instruction. Oh, you know what? I've got to. I forgot to put the ammeter in. So we're going to use this meter. I virtually never make ammeter readings here. Milliamps. 315 milliamps max. And I'm nervous using a current meter. Okay, as you should be. I'm nervous. Set this to, oh my gosh, this thing, oh no, I'm reading it wrong. So 20 milliamps, 200 milliamps, 20 amps. Let's go 200 milliamps. It said put a meter with a 50 milliamp maximum scale. Let's get it to say. Yeah, when you're using an ammeter, you're playing around with a short circuit. You hook it up to whatever it is you're going to hook it up to. You're essentially applying a short circuit. Let's put it back here. Now, with any luck, oh, look at that, it's right underneath. Now there's instructions on how to hook the meter up. And the instructions are connect the milliammeter, grid and plate jacks use, a meter full scale 50 milliamp. Connect negative side to the plate jack. Okay, negative side, plate jack. And as soon as I put this in here, potentially this is a high voltage on the end of this, or weird voltage. I should really put the grid one in first. And reading the instructions again, because I've already got it messed up in my head. Black to the plate. Let's put it that way. Okay, let's do that. Black in the plate. Yeah, it goes right in. Now, can we get this into the grid? Probably gonna pop off. Milliammeter doing anything? No. Okay, I'm pretty sure we're in. Very nervous doing this. Okay. What's it say? Connect the negative side to the plate. Insert the 6L6. Wait a minute. Well, isn't the 6L6 supposed to be sitting in there, or in my case I'm doing this with a 50? Okay, don't know when the tube was supposed to have come out. It's in there, it's switched on. The test is actually half operating right now. Turn it around, 30 seconds. Bias for a potentiometer, bias potentiometer for 20 milliamps. I don't see any current there. Turn this one on, 30-second warm-up, adjust bias potential for 30 milliamps of plate current. There's no plate current. I don't have this switched on yet. Maybe that's what it is. So following the standard procedure, I'm kind of convinced now, when you do the line and the bias, you switch this to hold. Okay. There's still no current showing up. What's going wrong? It's supposed to be an AC ammeter, isn't it? It's an AC ammeter. Oh, it's a DC ammeter, for crying out loud. Okay, hold on. Never booted this up. Okay, so they've been clever enough to arrange the scales on this meter, so if you make this kind of mistake and you want to switch to the other scale, you're switching from the highest to the highest. It's an ammeter, right? So, taking this out, there's probably current flowing through there, we just couldn't see it. Put this on a 20 milliamp scale. Place this back in. This is on test now. There's no current flowing. What is going on? This is correct. I have this set to line and not test. That's what's going on. Okay, so if we look at the line reading, that's what's going on. Look at the line reading. Look, okay, lots of things going on here in the background. That's the line. Here's the bias. Right, there was a special bias. Where'd the bias go? It disappeared entirely. This is not good. The bias is supposed to be set high on this test, isn't it? Sorry, turn on, 30-second, adjust bias for 20 milliamps of plate current on the DC meter. There's nothing on that. There's nothing. I just didn't make connections here. How can you, like, that's a heavy current. How can I suddenly be, I'm just questioning the test here. Hang on, I got you looking at the meter there by accident. Take a look at this. I'm checking to make sure the leads are continuous from here to the meter, for crying out loud. That's how desperate I'm becoming here. So is this indicating something's wrong with this machine? Usually, no, it's me. I still haven't put this on the test. Oh, I heard a pop coming out of a speaker in my shop, so it's a big exciting thing going on here. Oh heavens, what was that? Oh, I'm turning the brightness. I'm losing, man, the plane's going down. We're crashing, man. Yeah, I watched Mayday just before I came in here, and basically a plane crashed because the pilots could not, it's just like my situation here. They're seeing information coming up and they can't register it fast enough, and literally this plane fell out of the sky within about 30 seconds with the pilot still trying to figure out what's happening. What actually happened was the lead pilot shut off the two main computers simultaneously, and the plane just fell out of the sky. Can you believe it? That's actually what happened. Yeah, so don't shut off your main computer when you're flying. There's still nothing on here. Oh my god. This is on test. This is on test. This is on hold. No current flow. It's the first time I've attempted this EM test. Why would there be no current flow? Settings are wrong. Okay, settings are wrong. BEBD. BEBD. 6. Okay, this thing may not be making contact or may be burned out. This is the first time I've tried an EM test. You know, the only reason I'm thinking that this test isn't working is because I'm seeing no current here where I think I'm supposed to see some current, but the meter's gone up nicely. It's way up in the good. In fact, if you look, have a look. It's good. Hey, that's enough. Tube's good. This tube is good. The tube is good. The test has worked. What hasn't worked is my ability to do this calibration thing. There's gotta be something I'm missing here. Is there some reason to think this isn't set right? How can this not be set right? I wonder if there's a voltage there. Pull that out. Hopefully it's not depending on this current flowing through this meter to avoid blowing up or something like that. Is there any voltage there? The test is in place. Test. Jumping around like that usually indicates it's probably AC. 1 volt AC. Can't get too excited about any of this. So there's an AC voltage there. It said DC meter, didn't it? Didn't it? Connect a milliamp meter DC from grid to plate jacks on the front panel. Connect the negative side to the plate jack. I think you're supposed to just simply, you should see current on that. There's some other thing I missed here earlier on. Is there some wiring change? Some temporary change? No. So there's something wrong with the machine is kind of the next conclusion. The current that's supposed to show up here isn't showing up. Plate current on the DC milliammeter. Okay, back to it. There's no milliamp scale here. Just want to make sure this line bias, line adjust isn't getting super hot. It's definitely warm. I just realized the fuse light is on over here. The fuse light is on, and so oh. Okay, so there you see the fuse light is on. It's not on full tilt. I think if I take this off test, oh, it's still showing up a little bit. Hey, there's current flowing in the current meter. What? There's current flowing now. I put this on test. Okay, so I have no idea why suddenly it's decided to flow current here. Did I do something? I don't think I did anything. Okay, so I was just working on the video you're watching and getting it ready, and just like those of you who view my videos, I could see my mistake I was making that I didn't realize at the time I was making it. So the mistake is still sitting here. And what happened was I switched this meter over to make a voltage check, and when I switched it back to current, I never moved this lead. So from then on, the meter's going to say 0. So I'm going to move the lead, and we're going to repeat this test. I'm still not very hopeful about it, but I can't say I ever got the machine into quite the right state for this test. Everything should have been left just the way it was. It didn't do anything to anything. At least I don't remember. Here we go. So we're hoping to use the bias control to set a current of 20 milliamps here. where's the current? Where is the current? Where's the current? Still no current. Now what am I doing wrong? Well, I was pretty hopeful that was going to fix the situation, but no. Ooh, what was that? What did I just hear? Okay, lots of things are... Oh my gosh, where's... Oh, lots of bad stuff happening here. I don't know what happened there. Okay, so one of my problems, just as last winter, one of my ears is blocked right off. My right ear is blocked off. I can't hear anything over here. So I haven't said anything about this. While I'm standing here, I hear sounds. The sound could be from over there, but I hear it from over here. That just totally confuses me all day long. So I don't know what just happened. I heard some funny sounds off to my left. I don't really know where they came from. I certainly heard the hum of the heavy load on the unit. I saw the fuse light come on. Too many things are going wrong here. Yeah, I'm gonna call it a day here. Because man. Okay, thanks a lot for watching, and boy, I hope I have a better time tomorrow. I'm gonna spend my day here and there reviewing all this stuff and see if I can't sort out what is going on. I do not want to conclude that there's a defect in the machine. I'd much rather believe I just haven't done something right yet to make this test work. So thanks a lot for watching, and we'll carry on tomorrow. Here we are. Just a beautiful, beautiful day out here. So thanks a lot for coming and watching me fight my struggles here. And see you tomorrow. I'll think about this today and do something tomorrow.